Okay, so everybody, it says simplify the following and state the restricted values. So what would we pull out? We know to simplify, we factor, correct? Factor the top, factor the bottom. Well, what would I pull out on top?
7x squared.
I like that. 7x squared. So then divide by 7x squared, divide by 7x squared. What's left in my parentheses?
2x plus 7.
Good. Don't say it like that, because then it's annoying. Just put normal under. Okay. Okay. Yeah, just 2x minus 7. Okay. On bottom, what do I pull out? You're right. 7x, divide by 7x, divide by 7x. What's left in my parentheses? Was everybody able to get that far? Okay, good. Now let's restrict. Because remember, this is what's really sad. People will get to the test and they'll divide and then restrict. That's so sad. 7 will never be 0. X cannot be what right there? 0, because 7 times 0 is bad news, right? Yeah. There's my first restriction. X cannot be what for that piece? -1. Now we can divide out exact factors. Don't be mistaken. These are not connected. Well, they're connected by a multiplication sign. If there's a multiplication sign, we can divide them out. 7's divide out, x squared and x. What will we get? 1x on top, won't we? And then nothing else. So my final answer is x times 2x plus 7 on top. And on bottom, x plus 1. Raise your hand if you got it right. Very good, very good. Most of you, okay. A lot of you were able to get pretty far though, so that's good. Now just look at this, for example. I don't want you to do these on a whiteboard because I'd rather go quick. But I want you to look to remember because this is what's going to separate on the test an A from an A minus. Does that make sense? So everybody, what did we learn yesterday that we need to do when we see something like this? We need to switch it, reorder it in standard form. So just watch maybe. On top we have negative W plus 9. On bottom, well, that's good to go. Negative W squared plus 81. Now it's not considered factored if we have a negative in front. So when we factor the top, won't I pull out a -1? Left is W minus 9. Is everybody feeling okay about this? Okay, perfect. On bottom, shouldn't I factor out a -1? Then left is W squared minus 81. All right, now let's look at this. Is it factored completely? No, the bottom can continue to factor. What multiplies to be -81 and adds up to be 0. Yep, so then this quick factor, so on top, I would rewrite it, -1, W minus 9. On bottom, we had a -1, we had a W plus 9, and a W minus 9. Okay, let me restrict real quick. -1 will never be 0, W cannot equal, and 9, you're right, and then these divide out. And then don't my -1s divide out. So what was left on top? 1 over W plus 9. Does everybody see how that worked out? So same thing here, right? We would need to rewrite the top and continue to factor it. Do you want to go through it for practice or are you feeling pretty good about those? Like, I don't need to do more. I'm good. Okay, let's move on. Today we're doing 4-2. We're going to be multiplying and dividing rational expressions. Now you're going to see this is actually really easy. It's almost exactly what we did last time, but one extra step to start out with. So I'm just going to show you something to make a point here. Okay, I'm trying to make a point. So the rule is when multiplying fractions, you can literally multiply straight across. You do not need a common denominator. All you have to do is multiply the numerator, multiply the denominator. So watch how I could do this. 2 times 6, I could multiply together. Don't I get 12? Yeah. On bottom, 3 times 4 is 12. That would be my answer. Now let's simplify the answer. What's 12 over 12? 1. Now let me show you how we would do it in an easier way. We can actually multiply this out and get something large here like 12. We can multiply this out and get something large here like 12. Now because we're familiar with numbers, this isn't hard though, right? Even though it's 12 and 12, it's not that hard. We can simplify that. But watch an easier way. So we know the rule is we can multiply straight across. Well, we are not going to actually multiply 2 times 6. Let's just rewrite it as, I'm trying to make a point here, 2 times 6. Isn't that the same thing as 12? Yeah. And on bottom, I have 3 times 4. Yeah. Same thing as 12, isn't it? Why multiply it together when we then have to refactor it and divide it out? Does everybody see my point here? Now I can divide exact factors. So let's see. 2 and 4 divide out to be 1 and 2. 6 and 2 divide out to be? 6 and 2 divide out to be? 3 and 1. And then 3 and 3 divide out to be? 1. So do you see how I got 1 in technically an easier way? Well, it wasn't easier because we were dealing with numbers. But what if we would have been dealing with factors? Would you rather factor something when it's all multiplied together or already have it halfway factored for you? Halfway factored. Do you see my point here? If we're dealing with polynomials, would you rather have the polynomial all multiplied out or less factored? What's going to be easier to simplify? Factored form.
Yeah, that's
Are you guys seeing the point of this?
Yeah, could you redo the easier way? I got lost.
I didn't get it.
Okay, so we had 2 times 6. Let's do it like this. Let's factor it completely. What is 6 factor to be? 3 times 2.
Oh, okay.
On bottom, what is 4 factor to be?
2 and 2.
Now look, can't we divide across multiplication signs?
Oh,
2s, 2s, 3s.
Okay, yeah.
Is that better? Okay, sweet. So that would be easier technically, especially when we get to something like number 3. So everybody, here we go. This is number 3 on the worksheet. The rule is when multiplying fractions, you literally multiply straight across. So rewrite the problem. We're doing 5w minus 25 times w. So do you see how I literally just rewrote it? It's like the same thing. Now on bottom, we have 5w minus 10. We're multiplying straight across times w squared minus 25. Now my point was, for this reason, would it be smart for us, we could do this, but it would be making our life harder. Should we take, isn't that my answer, now I just need to simplify it? Well, what if we would have taken w and taken the liberty of multiplying this in? Then what would our next step be? Factor it back out. Do you see the point of leaving it factored? That's what I was trying to show you.
You don't want to do that.
No, because then our last thing is to simplify, and then we have to factor it right back out. Does everybody see why I'm saying don't multiply it together? Leave it factored. Now, once again, if you were to multiply this out and combine like terms, you're going to have this huge polynomial you have to know how to factor, and you're not going to be able to. So why not leave it factored? Okay, so now you'd say that's my answer, but now I need to simplify my answer. How do we simplify? Well, that's what we just quizzed on. You factor the top, factor the bottom, divide out exact factors. So let's look in sections here. Let's factor this piece. What should I pull out? A 5. So then left is w minus 5. Am I right? So then we have times w still. So we have 5 times w minus 5 times w. Does everybody see where I got all that? Now on bottom, let's factor the bottom. What should I pull out here? 5. Left is w minus 2. What should I factor this piece to be? Well, multiplies to be negative 25 and adds up to be 0. 5 and negative 5. Can I quick factor? Yes. So this factors to be w minus 5, w plus 5. So now I'm going to go write that over here. So we have a 5, a w minus 2, a w minus 5, and a w plus 5. Does everybody see how I've just rewritten it completely factored? Now, a lot of people get thrown off here. I just want to point something out. Sometimes students find it easier if you reorder this in the prettiest form. So technically on top, the prettiest form would be 5w, w minus 5, and I always think that does help. And then you have a 5 on bottom, a w minus 2, a w minus 5, and a w plus 5. So putting it in a prettier form just kind of helps. Okay, let's restrict and then divide out exact factors. 5 will never be 0. W cannot equal what for here? 2 for here, 5, and for here? Negative 5. Please, if you really don't understand that, say, wait, can you explain that? And raise your hand. Okay, do you need me to explain it? Okay, sweet. So now, we can divide out top and bottoms, correct? As long as it's an exact factor. Now careful, we can always divide across multiplication signs. So 5's divide out. W doesn't divide with any W's on bottom. W minus 5, W minus 5. So boom, there's my answer. W over W minus 2 times W plus 5. Very good. Okay, perfect. Now understand one thing, everybody. I could multiply this out, but why when I can leave my answer factored? Why do extra work? Does that make sense? Wasn't that pretty easy? There was literally not really much more than what we did last time, besides it just had more factoring involved. All good? Let's do another one. Flip to the back page, like the blank page. Take down some notes here, just the blue blank page. So here's my first example. Write it down for yourself, because you're gonna want to refer back to it for your notes. So it says, what is the product? That means multiply, and then state any excluded values. So remember, when multiplying fractions, you can simply multiply straight across. So we have 6 times -2 on top, and on bottom we have a squared times a cubed. Right?
What is rewriting?
That's the point. It's literally, it's me going like this, isn't it?
Yeah.
Yeah. Okay. So do you see though, that's literally the answer. Now we need to simplify. So how do we simplify? Divide things on top with things on bottom. Does anything divide out in this one? No. So that's our final answer. But let's restrict. A cannot be what for that piece? 0. What about that piece? 0. So A cannot be 0. Does everybody see why? 0 to the second power would be 0 times 0. That would make the denominator 0. 0 to the third power would be 0 times 0 times 0. That would be bad. We can't divide by 0. Yes.
When was the, said like anything, when was the restriction like not to 0? Because anything like 0 would make it
Like here,
yeah.
2 and 3 would be the restrictions, right? Because that would make the denominator 0. Okay. Okay, now let's say, okay, so since nothing divides out, there's our answer. However, with this one, since I'm going to put it together, just because with this one we would. 6 times -2 is -12, isn't it? And on bottom, let's see if you can get this right. Let's see if you'd be that person that messes up. When you multiply, you add a to the 5th. So there's our answer. That's a comma. So -12 over a to the 5th, as long as a does not equal 0. Okay, let's do this next example. Write it down. X over x minus 2 times x plus 1 over x minus 3. When multiplying fractions, we can literally multiply straight across. X times x plus 1. Now, once again, we're not going to take the liberty of multiplying this in, because then our last step is factor and simplify. Well, this one's already factored, so why multiply it in to then refactor it back out? On bottom, we have x minus 2 and x minus 3. All right, now you'd say, that's my answer. Does my answer simplify? And let's restrict our values. X cannot be what for that piece? 2 and 3. Now let's divide out exact factors. Do you see anything? Nope, so there's our answer. It doesn't simplify. Pretty easy, right? Okay, cool. Yeah.
If you were multiplying it,
Uh-huh.
why don't we use the original? This would be a combination.
Uh-huh.
And make it x squared half one. X squared x. Like, one combination.
So if we were multiplying this out, we would have to double distribute, right?
Yeah.
You could write x squared plus x. You could, but then the thing is we then would have to refactor it to see what divides out, and we'd end up back here. Good question. Okay, let's do another one. You're writing this down on the blue paper. I'm going to be checking for this to give you a 10 on your assignment. Okay, so we have b over 2 times 6 over b cubed. It says multiply and state the excluded values. So once again, when multiplying fractions, we literally just multiply straight across. So we have b times 6 on top, and on bottom 2 times b cubed. So yeah, it's literally like rewriting what we already have. That's why it's almost silly, because now our last step is to simplify. All right, let's restrict. 2 will never be 0, but this piece would be bad news if it was b cannot be what value? 0. Does everybody understand why? Now let's divide out exact factors. We have a b on top and a b cubed on bottom. So won't this b cubed become b squared? You're right. 6 and 2 become 3 and 1. So left on top was a 3. On bottom, a b squared. So it's not too bad, right? Especially because you guys did really, really well on that factoring quiz. You can get on Skyward and see what you got. And if you're curious to see what you missed, you can get it integrated and recorded later. Okay, let's do this one. Write it down. This one, things are going to divide out. So we have 14x divided by x squared plus 3x minus 10 times x plus 5 over 7x minus 21. Once again, you should be saying in your head, multiplying fractions, we literally just multiply straight across. So we're going to have 14x times x plus 5 on top. And on bottom, we're literally going to have x squared plus 3x minus 10 times 7x minus 21. And once again, I always see these poor unfortunate souls on the test start multiplying this out, getting a huge thing on bottom, and then not being able to simplify it because they can't factor it because it got so big. Does that kind of make sense? So leave it and factor it in sections. Now look at the top. The top is already factored. Now let's look at the bottom and factor it in pieces. Well, multiplies to be negative 10 and adds up to be 3. Very good, negative 2 and 5. And we can quick factor. So this piece factors to be x plus 5 and x minus 2. Let's factor out a what here? A 7. Now we're ignoring this for a minute. We're just focusing on this and factoring it. So we have times 7 and then x minus 3. Now this always gets people. I highly recommend just rewriting the whole factor answer here. So rewriting it, we have a 14x on top times x plus 5. And on bottom, now that we've factored this completely, look at it. It's all multiplication. Couldn't I put the 7 in front? So let's do that. 7, x plus 5, x minus 2, and x minus 3. And now look, I've rewritten the entire factored answer so that we can then look at it easily and not miss anything. Let's restrict. X cannot be
0.
Well,
Negative 7.
no. Think about it. Is 7 ever going to be 0? No. So there's no restriction right here. Does that make sense?
Oh.
There's no potential for 7 to become 0 because there's not a variable there. X cannot be what here? What about here? And here? Okay, perfect. Now we can divide out exact factors. So look, this is just multiplication. We can divide across multiplication here. All right, 14 and 7 becomes 2. X, nothing on bottom. X plus 5's divide out. So what was left on top?
2.
Yep, and on bottom we have our x minus 2 and x minus 3. Now once again, if this is a multiple choice test, you might see the denominator actually multiplied out or you might not. Why multiply it out though if you don't need to? Does that make sense? Are you guys feeling okay? I cannot quite tell. Okay. Go to the worksheet now. Let's start doing some examples off the worksheet. Number 1. Here we go. When multiplying fractions, don't we multiply straight across? Are we all with me? So I like that you're putting the 3 in front. And then on bottom, should we maybe put the z in front because it's prettier? Why not, right? Z times 4 plus 5z. Let's restrict, and then we can divide out exact factors if there is any. So for this piece, z cannot equal what? 0. Now for this piece, it gets people. A lot of people can't do it in their head. So if you can't, say our choose statement is 4 plus 5z simply can't be 0. Solve for z. What would I do first? Nope, see, it was hard to do it in your head and get it right? Let's just do the algebra. So 5z equals negative 4, am I right? Divide by 5, divide by 5. Does everybody see how I got that? I just set it equal to 0 and solve. So z cannot equal 0, and z cannot equal negative 4/5. Let's divide out exact factors. Do you see any exact factors? Nope, so that's my answer then. Didn't simplify. Pretty easy stuff. Do another one. Number 2. When multiplying fractions, don't we multiply straight across? Should I actually multiply it out together? Should I? No. Okay, let's rewrite it. So we have x times x minus 9 on top. And on bottom, we have x plus 7 times x minus 6. Let's restrict. X cannot be or 6. Divide out exact factors. Anything to divide out here? Nope. There's our answer then. look, you're a hippie too. We're so cool. Okay. All right, now let's get to some of the caliber we're going to be at. This is the more advanced level. The rules don't change though. When multiplying fractions, you multiply straight across. So everybody, get out some major paper for this one. Here we go. We got it though. We can do hard things. We're in the advanced math class because we want to be advanced. Here we go. Yeah, these are just cues. This is number 7. You're going to need some major paper. So when multiplying fractions, we multiply straight across. So let's rewrite what we have. 45 q squared minus 3q minus 6 times 14q squared plus 10q, right? And on bottom, we have a q squared times 35q squared plus 11q minus 10. We would not want to multiply this bad boy out because then your final answer needs to be factored and you will not be able to factor it. You'll be stuck. Leave it. You say, that's my answer, now I need to simplify. How do we simplify? Factor the top, factor the bottom, and divide out exact factors. So this one is only hard because there's a lot of factoring involved. So everybody, let's focus right here. Let's factor this out. Now I'm going to ask you a question. I'm going to make a little bulletin point for myself to keep my work. The hardest thing is keeping your work straight. So factoring the quadratic. Well, first of all, what can I pull out right here, right now? Okay, let's do it. Pull out a 3, divide 3, divide 3, divide 3. What's left in the quadratic? Take your calculator. 45 divided by 3. So we have 15q squared minus q minus 2. Does everybody see? Then you'd say, well, I'm not done factoring that piece. I've got to factor the quadratic. Let's do it. What multiplies to be a times c, what multiplies to be negative 30, and adds up to be negative 1. You're right, 5 times 6 and a negative 6. Now careful, it doesn't quick factor. So now we've got a drop and break. We're ignoring 3 for a minute, but not forgetting it in our final factor. So we're dropping down 15q squared. We're inserting these in, so plus 5q minus 6q, and then we're dropping down negative 2. Let's factor by grouping. I'm going to scroll up for a second. So in this group, we would pull out a 5q, am I right? So then what's left? Yeah, so 3q plus 1, you're right. And right here, we'll pull out a negative 2, divide by negative 2, divide by negative 2. So left is 3q plus 1. We know we've done it right because our safe haven is the same, so pull that out, 3q plus 1. Left is 5q minus 2. We've factored the top, but what can we not forget? 3. Now all of that was just to factor that little piece. Okay, now that's okay though, we can keep going. So we'll now make a special spot. Go off to the side and make a little box and say, I've got to put my final factors in this box. So this piece, I would highly recommend rewriting it real quick in a box. So we have a 3, we have 3q plus 1, and we have 5q minus 2. Because the hardest part is keeping your work organized, to be honest. All right, now I'm going to erase this to give myself some room, but you would just kind of get yourself more paper. Okay, here we go. Let's factor the next piece, everybody. Are you all doing okay? Here we go. Factoring the next piece here, this piece. What should I pull out? Yep, 2q, and then divide by 2q, divide by 2q. What's left inside? 7q plus 5. Do we know how to factor? Are we doing okay? I know. So now we would go off to the side up here. Didn't we also have a 2q and a 7q plus 5? There's our top completely factored. Do you have questions you got to ask if you do? Yes. You know, that's a great idea. He makes a good point. Wouldn't it be kind of prettier to put 3 times 2q together? I like it. Let's do it. Let's kind of go down here and say, okay, so really we're putting our final factors here. So that's 6q. And then we still have 3q plus 1. We still have 5q minus 2. And we still have 7q plus 5. Okay, let's now factor the bottom. Q squared is good to go, so we can go ahead and add that to our denominator over here. But now we're going to factor this piece. So let's do it. Here we go. It takes some dedication. We can do it though because we're dedicated. That's why we're here. We're choosing to be here. Well, multiplies to be negative 350 and adds up to be 11. Now it does take some dedication. If you don't know, start listing out factors. Ready, go. Find the factors for me. Grab your calculator. Don't look into it. Okay, you've already got it. 40, wait, what? 14 times 25. So do you see how they went through? They were dividing by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and they found it. Does that make sense? Okay, so which one's negative? Now we'll drop and break. Here we go. We can do hard things in here. And this isn't, I mean, this is just harder factoring. So 35q squared, negative 10. And then we rewrite the middle terms as minus 14q plus 25q. Now we'll factor by grouping. We'll pull out a 7q, I believe. Divide by 7q, divide by 7q. So then left is 5q minus 2. Right here, I'm going to pull out a 5. Divide by 5, divide by 5. So then left is 5q minus 2. So we can pull out 5q minus 2. And left is 7q plus 5. So now I'm going to go over to my final factor piece, the square with my final factors in it, and write that in. So we had a q squared, and now we have a 5q minus 2 and a 7q plus 5. Okay, let's now restrict. So the hardest part was just factoring each piece correctly. Now we can restrict. Q. Remember that Mason made a good point. Couldn't we put 2q and 3 together to make 6q? Oh. If we wanted. Oh, yeah. Not a necessity, but I liked the idea. Just because it's writing it in the prettiest format. Okay, let's restrict so we can get our final answers. Oopsies. Q cannot be what for that piece? 0 for that piece? You're awesome. And for this piece? Okay, very good. Is everybody caught up mentally? Now we're to the easiest part. Divide out exact factors. So we have a 6 on top. Anything that can divide out with 6 on bottom? Nope. A q on top. Can it divide out with a q squared? Yep. It's multiplication. So will this just become q? It's a q. Everybody with me? 3q plus 1? No. 5q minus 2? Divides out, doesn't it? What about 7q plus 5? So my final answer is 6. Yep, 3q plus 1. And on bottom we have a q. And that's it. So we're done. So it's not that it's necessarily super hard, but I'm not going to say that it didn't take a lot of work. It was a lot of hard factoring, but once again, this is the advanced class. You guys are doing awesome. Okay. Okay. So let's go to the second page now. Same thing though, we're not learning anything new. We're just continuing to practice so that we don't get confused at all here. Because a lot of you are kind of still struggling on like, I don't know, making little errors. So here we go. We know when multiplying fractions, you literally multiply straight across. So let's rewrite this one. 7 times 9p squared minus 15p. Then on bottom, we have 9p cubed minus 15p squared times 3p. Now we know that's our answer. We technically multiply these. Now we've just got to simplify. We simplify by factoring the top, factoring the bottom, restricting, and dividing out exact factors. So on top, we have a 7. Good to go. Let's factor this piece. What should I pull out? A 3 and a, you're right, a p, right? Divide by 3p, divide by 3p. And once again, I make a special spot where I put my final factors over there. So then left was 3p minus 5, am I right? Right here. So on top, we had a 7 times 3p times 3p minus 5. Now, if you would like, you could rewrite that as 7 times 3 is?
21.
We could write that as 21p times 3p minus 5. Okay, let's factor out the bottom. So right here on this piece, what do we pull out? A 3p squared. Way to see that. Divide by 3p squared. Divide by 3p squared. So then left is 3p minus 5. And then we have a 3p as well. So we have a 3p squared, a 3p minus 5, and then on bottom we still have that 3p from right there. Now once again, a lot of people like to reorder and say, well, isn't this prettier to rewrite this as 9p cubed? Okay, I agree, it is prettier. So on top we have 21p times 3p minus 5. And on bottom, we have 9p cubed times 3p minus 5. Now I've just written it in the prettiest format. Now we'll restrict and then divide out exact factors. 9 will never be 0. P cubed, p cannot be right here. 0. And for here, you're right, 5/3. Very good. Divide out exact factors. Now, a lot of you on the quiz in this class, this is what you missed. So everybody listen. You said, oh, 21 and 9 don't divide out. Just because they don't divide perfectly doesn't mean we don't simplify them. Don't they both divide by 3? Yes, good. You guys didn't miss that on the quiz. Okay, so 21 and 9 divided by 3. So this would become a 7. This would become a 3. And then p and p cubed. Won't that become p squared on bottom? And then these divide out. So left on top was a 7. On bottom, we had a 3, a p squared, and nothing else. Oops. So there's my answer.
And what number is that?
This was number 1 on page 2. I hope this is continuing to make sense.
So is this literally all we're doing?
Yeah. Okay, so do 2 on page 2. Go to number 8 on page 1. Let's do it together. This one throws people off because they kind of get confused and they say, okay, well, what's going on here? But don't let it throw you off. This is technically divided by 1. So multiplying fractions, we just multiply straight across. So let's rewrite what we have. That's on top. And then on bottom, we have 2y minus 3 times 1, which is literally 2y minus 3. Make sense? Okay, that's my answer. Now I just need to simplify. We've simplified by factoring the top, factoring the bottom, and dividing out exact factors. This piece does not factor. So once again, I'm going to have a place where I write my final factored form before I divide it out. Number 8, thanks. Let's factor this piece. Here we go. But we can do it. You just got to get dedicated and say, I can do it. Here we go. And what multiplies to be 8 times c? Thank you for your help. Negative 1,248 and adds up to be negative 22. I want you all to get dedicated and start finding those find the factors. You already got them? What is it? 48 times 26. This one would need to be negative. You're right. Very good. Thank you. Now we have to drop and break. So once again, drop and break. Let's go. 32y squared minus 48y plus 26y. And then minus 39. So now I'm going to factor by grouping. We would pull out what here? We could pull out 2y. That wouldn't be the greatest thing in common. And 8. Let's try 8y. So then divide by 8y. Divide by 8y. What's left? Now look at 4 and, okay, this is a good point to make. Look at 4 and 6. Shouldn't we have pulled out another 2, actually? So what we should have pulled out was 16. Very good. Does everybody see how he got that? Okay. So I'm going to say, okay, actually, let's go back. Let's pull out a 16y. So divide by 16y, divide by 16y. So then left is 2y minus 3, everybody. Now right here, we're going to pull out 13. How did I get that hint? Because I kind of looked and said, I need this to be 2. So I pull out a 13. But you got to make sure it works. And it does. So then left is 2y minus 3. So we would pull out 2y minus 3. And left is 16y plus 13. So now once again, have a little spot where you put your final factors. So that piece just became that. Over here's where I'm writing my final factor stuff. So we have a 2y minus 3, and we have a 16y plus 13. Now we can restrict and divide out exact factors. Y cannot be. Oh, thought I had a pen. Okay, y cannot be 3/2, you're right. And now we'll divide out exact factors. So isn't my answer 4y plus 17 times 16y plus 13? All over 1. We don't need to write all over 1. Okay. Now what I want you to do is 9 and 10 on that front page and check them off with me. I'm giving you as much time as possible, but it's taking long because we're factoring wrong. So focus, factor right. Here we go. Go to 14 on the back of page 1. Listen to the rule. We have one rule to learn. One more rule. Dividing, everybody listen to the rule. Dividing fractions is easy as pie. You flip the second fraction and you multiply. So everybody, dividing fractions is easy as pie. You flip the second fraction and multiply. Don't we already know how to multiply? Okay, let's do it then. So we have 5y plus 7 divided by 3y plus 19 divided by 5y plus 7 divided by y minus 6. This literally means flip the second and multiply. So let's rewrite what we're looking at. 5y plus 7 divided by 3y plus 19. Flip the second and multiply. So put a multiply sign. We have a y minus 6. And on bottom, a 5y plus 7. Do you see how that is really easy? Because we already know how to do that. Okay, don't forget that saying. Okay, now let's simplify it. So we know when multiplying fractions, we multiply straight across. We have 5y plus 7 times y minus 6 all over 3y plus 19 divided by 5y plus 7. Now you'll say, okay, I need to factor this out. Nothing factors, so restrict. Y cannot equal negative 19/3, am I right? And it can't equal negative 7/5. Now divide out exact factors. So my answer is y minus 6 over 3y plus 19. Yep, it's really quite easy because it is just multiplication. Let's do another one. The same thing we just learned. Yep. 15 and back. 15 on back. Moving on. Dividing fractions is easy as pie. Flip the second fraction and multiply. Here we go. So we have 25 I squared. Now I is just a variable here. Not like, that's not I squared, imaginary squared. Over 56i. They're just using it like if they were using an egg. Okay. And then we flip the second, so 8i goes on top, and now we're multiplying. And then 5i minus 6 goes on bottom. So let's multiply straight across. We have 25i squared minus 36 times 8i, and on bottom we have 56i times 5i minus 6. Now we've got to factor each piece and divide out exact factors. Here we go. We'll multiply to be a times c. I think that's negative 900. And adds up to be 0. Is it 25 times negative 36? Calculate it for me. Yeah? It is? Okay, so then what are the two factors? What times what equals 90 that are the exact same thing? What? No, flip the second and multiply. Okay. Yeah, 30 times negative 30. Okay, now we got to drop and break real quick. So we have 25i squared minus 30i plus 30i minus 36. Do you guys see what I'm doing? Dropping and breaking? Yes. Okay, what you're doing, yes, but what you're doing, you're meaning talk to me later. Okay, continuing to factor. So we'll pull out a 5i, won't we? Everybody, 5i minus 6 is left. What will I pull out of here? A 6. Left is 5i minus 6. So then we have 5i minus 6, and then no, we have 5i plus 6. Okay, sweet. So we just factored that piece. Let's remind what we have. If I can fit it somewhere. So we have, that, 5i plus 6, 5i minus 6, and then no, we have an 8i. Can't I write it in front? Is everybody with me? 8i, I just put in front here. You good? Then on bottom, we have a 56i and a 5i minus 6. Let's restrict and divide out. So I just rewrote the final factors right there.
Well, it can't be 0.
Okay, you're right. I cannot be 0 and 6/5.
Oh,
You're doing good. Now look, 8 and 56 becomes 1/7, doesn't it? My i's divide out. These divide out. So left is 5i plus 6 on top, and on bottom we have a 7. So guys, the hardest part is you've got to be good at factoring. And a lot of you are seeing that when you mess up, it's way harder than if you were to go slow and get it right. Okay, here we go. Okay, I think you're probably good with these unless you want to do some more. Are you good? Okay, then I'll tell you which last one we have to do, because if not, you'll be thrown off. We'll go to number 9 on the back page. Last one. A lot of people get thrown off just because it's written differently. Isn't this just division, just written differently? So dividing fractions is easy as pi. We flip the second fraction, don't we? And multiply. So we're going to go ahead and flip this one. Put x squared on top. On bottom, we're going to put x minus 4. Flip the second and multiply. So on top, we have y plus 3 times x squared. On bottom, we have an x times x minus 4. Now let's restrict. X cannot be 0 and 4. Divide out exact factors. Y plus 3, nothing. No y's on bottom. No y plus 3 is on bottom. X squared and x. Yep, x up here and gone here, right? So my final answer is x, y plus 3 over x minus 4. Can I divide those x's? Good, because you can't do that across the subtraction sign. I was testing you. And you passed. Good. So don't let it written like, when they write it like that, don't let it throw you off. Yeah. I'll tell you which ones we're doing. But since you asked, I'm annoyed. So maybe I'll just assign them all. Okay. Okay, so what you're going to do is flip to the second page. The back of the first page, really. Sorry. The back of the first page. Go ahead and cross out 16 through 24. I didn't even hear what they said. Did anyone else hear? Okay. So basically, we're not doing the back page. Now, here's why. Because you'll get in enough practice everywhere else. Now, be honest. Look at what we've done in class. Look at what I'm assigning. Isn't that quite a fair amount? Hey, you still have about 10 minutes, well, a little under 10 minutes of class. Finish a couple more, check them off with me.